Finding the distance between 2 points is a commonly occurring problem. We would like to write a function that takes in 2 points and computes the distance between them. And when we say distance, we're really talking about the Euclidean distance between the 2 points, what we usually mean when we talk about distance. Let's first look at the geometry of the problem in 2 dimensions. Let's start by drawing our coordinate axes. In this case, I'm going to call this axis x and this one y, as is common in geometric problems. Let's have one data point here, and this has specific coordinates. I'm going to call this x1, y1. The second data point that we have is, let's say, in this upper corner here, and it has coordinates x2, y2. The distance between these 2 points is this line here, the length of this line, which at present is unknown. To determine that distance, we can do the following. We know that the length of this line over here is going to be x2 minus x1 as long as x2 is greater than x1. If we want to be sure, we can just take the absolute value of this difference. The second thing we can do is we can determine the length of this line over here, which is y2 minus y1. Again, we can take the absolute value of that. Now we know from Pythagoras' theorem what the distance of this line over here is. I'm going to call that d. Now we can write down the distance squared, d squared, which is given by x1 minus x2 squared plus, I'm going to remove the x here to give us a little more space, plus y1 minus y2 squared, and distance itself is going to be given by the square root of this entity. Because we're squaring the difference here, it doesn't matter if we write x1 minus x2 or x2 minus x1. The result is the same. And between these two terms, we have a plus sign. Let's try implementing these basic mathematical ideas in code. Since we're dealing with vectors, we'll be using NumPy for this. From a mathematical perspective, it would be nicer to use column vectors, but we'll be using row vectors because they're easier to deal with in NumPy. We will first import NumPy as np, and let's define 2 data points. Our first data point is going to be a row vector of 1, 1. And our second data point, our point P2, is going to be a row vector with elements, let's say, 4 and 4. Let's run these. Now if we type P2 minus P1, we'll see that NumPy returns an array, in this case 3, 3 array. Our next step is going to be to take this difference and raise it to the power of 2. We'll be using the NumPy power function for this. At this point, what we have are the squared differences between the x and y coordinates of these 2 points. The next step for us to do is to sum over these 2 terms and finally to take the square root. We can now try running this, and the answer looks good. Let's try turning this code into a function. We'll start from the code we have. We'll be defining a function which is called distance. It takes in 2 arguments, p1 and p2, which are the 2 points we're interested in finding the distance for. We'll take the code that we have, we'll indent that, and let's write a brief comment line. What this function does is it finds the distance. Let's make that find the distance between points P1 and P2. The only remaining thing for us to do is to add the return statement to make sure that we return the distance to whoever is calling this function. We'll also take out these 3 lines of code. I'll move the import statement at the very top, and then we can move these 2 points outside of the function. We'll then call this function using the usual syntax. Let's try running this. Let's run the definition of the function. We can redefine p1 and p2, and then we can try calling the function. And we're getting the same answer as before.